Alright, Chapter 3, System of Linear Equations. 3.1, Solving linear systems of graphing. Goal, solve linear equations in two variables by graphing. A system of linear equations. System of two linear equations, two variables x and y, consists of two equations. Coefficients of the determinant equations can any of the coefficients of the determinant equations can be real numbers. Coefficients of the determinant equations can be any real numbers. Equation 1, 3x minus y equals 3. Equation 2, x plus 2y equals 8. Solution of the system of the two linear equations, two variables are in an ordered pair x and y and satisfies both equations. When you graph the system, the solution representative of the points or points intersect of the two lines. Solution of systems for it is always possible systems that have infinite many solutions or no solutions. Find the number of systems. You can find is how many solutions the linear system graphing equation are analyzing the graph. The number of solution linear system. Exactly one solution graph system is a pair of lines that intersect at one point. Line does not have lines that have different slope. System has exactly one solution. Identifying many solutions. The graph of the system is a pair of identical lines. The lines have the same slope and the same y-intercept. System has infinite solutions. Solution has no solution. The graph has parallel lines which do not suit. The lines have the same slope but a different y-intercept. The system has no solutions. 3.2, Solving linear system and substitution. Goal, solve system and linear equations in two variables by substitution. One way to solve a linear system without using graphs is substitution method. Solve one equation but for one of its variables. Substitute the expression from step 1 into another equation and solve the other variable. Step 3, substitute the value of step 2 into the revised equation from step 1 and solve and check the solution in each of the original equations. Three, solving linear systems by linear combination. Goal, solve system linear equation in two variables by linear combination method. Sometimes obtain the equation with the fractions when you solve one variable in linear system. The systems either to solve using a linear combination method. Linear combination is two equations. Equal equations are obtained by one multiplying one over both equations by a constant, if necessary, and adding resulting equations. 2. Multiply, if necessary, one or both equations by a constant so that the coefficients of the one of the variables differ only in sign. 2. Add the revised equation step 1, combining like terms, eliminate one variable, and solve the remaining variable. Step 3. Substitute value obtained in step 2 and either of the original equations and solve the other variable. Step 4. Check the solution of each original equations. Solution of linear system. Step 2 of the linear equation method is the coefficients of 0 for both variables. The system has no unique solution. If you get true equation 0 to 0, the system has infinitely many solutions. If you get a false statement such as 0 or 6, the system has no solution. So you had no solution, infinite solutions. Three, 4, graphic linear equation, three variables. Solutions example of three variables can be pictured in a three-dimensional coordinate system. The constructed system begins with the x and y coordinate, the horizontal plane, horizontal position. Draw the z-axis vertical line through the origin as shown. Points in two-dimensional coordinate system are represented as order pair. The point in space representing the order each point in space can be represented as an order triple, or x, y, z, such as 1x, 2y, negative 2y, 3z. Three axes are taken two at a time to determine the three coordinate planes. The plane is divided into 8 octants. The first octant is one for which all the three coordinates are positive. A linear equation is three variables, x, y, and z. The equation of the form is ax plus by plus cy equals d. As the constants a, b, and c are not all zero, the order triple is x, y, and z is a solution of the linear equation. Three variables of x, y, and z make the equation true. If the values of x, y, and z make the linear equation of three variables is solution an order triple is a solution of the linear equation. Three variables of x, y, and z make an equation true. The graph of the linear equation of three variables is a plane. The three dimensions coordinate system graphs equation of one or two variables are also plane. Plane ax plus by plus cy equals d intersect all three axes. Plane by equals cz d intersects y axis and z axis and is parallel to the x axis. Place cz equal to cz is equal to d intersects y axis and is parallel to the xy plane. 3.5. Solving system of linear equation in three variables. In lesson 3.1 through 3.3, we learned how to solve the system of the two linear equations in two variables. In this lesson, you will learn how to solve the system of three linear equation three variables, such as the equation shown below. You have equation 1, which is a standard form ax by through cz equal to d. You have your second equations and third equations. What we've done now is we've taken the x's, y's, and zeros and we've multiplied them by a solution set of the x, y, and z is a solution of the three equations. The solution is system above. If the lesson you've learned a linear equation of three variables is in a plane, the graph of these three such equations form a system of three planes. Intersection determines the number of solutions of the system. Exactly one solution. If the plane intersects a single point, the system has exactly one solution. Infinitely many solution planes are intersecting a line or a parallel plane is a system having infinitely many solutions. No solution, three planes do not intersect. The system has no solution. So we have one solution, infinite many solutions where the line or plane, the system, the planes intersect. Planes intersect. There's exactly one solution. Plane selected. Line or plane. No solution. Do not intersect. The three planes do not intersect. Linear combination method, three variable system. Step 1, rewrite the linear system in three variables. Linear system, two variables using linear combination method. Step 2, solve the new linear system, both of the variables. Step 3, substitute the values found in Step 2 into one original equation to solve the remaining variables. Step 4, check the solution of each of the original equations. Chapter 3, summary review. We've done system of the two linear equations, solving system of the two linear equations, substitution method, linear combination method, three-dimensional coordinate system, x-axis, order triple, octant, linear equation, three variables, system of three linear equations, solving system, three linear equations. We did solving linear system by graphing, solving linear system by substitution, solving linear system with linear combination, getting a linear equation in three variables, solving linear equation in three variables, Chapter 3 test. Chapter 4, Inequalities and Absolute Value.